So we have our little program from before. I recommend you watch the first video of this particular series on inheritance and casting. We then know that a B object can be masked as an A object for all purposes in the program. Now, if we take this into an array, for example, let's try to take this as an array. I'm just going to put a little system.out.println all plus signs so you know which object we're talking about, and I'm just going to paste this. If we have an array of objects of type A, basically my array A is saying I'm going to have an array of length 3 where I can fit objects of type A. Because B is also an object of type A, because B inherits from A, objects of type B are also allowed here. So what I will do is I will take out this line for now. I will say for int equals 0 to the length of that array, my array sub I equals a new B. Okay, a new B. And then my array sub I set a I plus 1. So just to recap, take a look at the video on arrays if you don't understand this, but just to summarize, my array sub I is basically an empty cell that can take objects of type A. A B can go in there because it's an object of type A. You see, we just did this in this example. Okay, if you're expecting an object of type A, I can give you a B. This can hold objects of type A, therefore it can hold a B. Now, as soon as I put the B in this cell of the array, this cell of the array becomes an object of type A. Remember, an object of type A. At its core is a B, but an object of type A, just like my AB was. And then I can call methods. Remember, this here is an instance of an object of type A, so I can say set A I plus 1, right? And then I have a little function print array, which will basically do this. It will, for each element in the array, for each element of type A in the array, just print the element.a, just print the element.a, and then we'll do something. Just print that element.a. Ignore the rest of that for now. Let's take it out. Okay, so just print the element of the array. So, if I compile this and run it, I get 1, 2, 3, right? Because I'm setting I starts at 0, so I set it to plus 1, that's 1, 2, 3. And it behaves just like an object of type A, although at its core is a B, right? Now remember, every time that we build an array of type B, in the constructor we're setting a variable B equals to 12. Okay? How do we recover that? How do we recover that variable? The same thing here. How do we recover the B part of this A object? The answer to this is casting B. Okay, casting B. So let's do it for this example first. Say I want to print out my AB.B. The way I cast it down to a B is because I know that at its core my AB is an object of type B. I can say B equals temp. That's going to be B my AB. What I just said here in this line is I say, remember the variable my AB that was an A? Well, try to see if at its core it's an object of type B. And if it is, then put it in temp, which is an object of type B. And then I can print temp.b in here. So let's compile it, run it. And look at this, here's our 12. Temp.b, here's the 12. Right? B equals 12. Here is our 12. We can recover it as long as we say, hey, remember that person walking in the street, treat it as a lawyer. Okay? Remember that AB variable walking in the street that was A, treat it as a B if you can. Okay? And then print the B. The same thing can happen here in the array. In the print array. So when we print the array, what we can do is to say, hey, and this element, which is of type A, this element of type A, in parentheses, I cast it to a B. I'm basically saying treat it as a B because I know that at its core it's a B, and then give me the B variable for it. Now in this case, because I'm not changing B variables here, they're all going to be 12, right? So let's compile and run this. Whoops, I have an error here that I will quickly fix. It says that print line element. There you go. I just had some legacy code from before. I'll compile it and run it. And we see it printed the elements of the array 1, 2, 3. Right? Here's the array. We're setting the A to 1, 2, and 3, and 12, 12, 12 because that's the B that was next to it. The B that was next to it. Okay? So again, just to recap, a subclass object can be disguised as a superclass. Okay? And then you will only be able to access the subclass elements that are overridden in the superclass, or the elements of the superclass themselves. Now, if you want to recover some of the things that you had in the subclass, you have to cast it down. Okay, cast it back to what it is at its core. Now, the problem here comes in. Just beware of one little error. You have to be damn sure that myAB is an object of type B to cast it down. If you cast it down to something else, okay, so for example, let's cast it down to a string, okay, it'll say inconvertible types, right? So myAB cannot be casted down to a string, right? So you can only say B. Now there is one caveat though. So let's create a class D that extends B, okay? So I'm going to create a class D, public class D extends B, or extends B, okay, or extends A actually. It's another class that extends A. It doesn't really matter. And then I have a public int D. That's all I have in my class. Okay. Save. If I try to cast this down to D, okay, let's say D for whatever reason. Variable B, now these have B's. Oh, it extends A, I'm sorry. Yeah, let's do extends B. So then a variable D will have everything that a D has plus a B, right? So now I compile this, and it compiles, and then when I run it though, it says Java lang class cast exception. Okay, B cannot be cast onto a D. What happens here is it tries to say, hey myAB, can you cast me down to a D? But this is only a B. At its core, it is a B. So you won't notice this at compile time because this compiles, but when you cannot cast down to something that the class is actually not. Okay? A B is not a D. A D is a B, but an object of type B is not the same as an object of type D, so the casting is going to fail at runtime. You're going to get an exception. It's going to compile. You'll be fooled to think that it works, but then when you run it, it might not work. So just be sure to always cast to the right type if and when you do the casting. Last note. Why is this useful? Well, because you can have an array of many things like A's and B's, for example, right? And depending on which it is, you might want to call certain methods, but you want to store them all in the same array. You don't want to have to keep track of several arrays, one storing B objects, one storing A objects, one storing D objects. You just want one single array. Say, for example, an inventory of cars. You don't want to be having an inventory of cars, an inventory of limos, an inventory. You just want one inventory of cars, right? Which is one array, and then everything, a limo, a car, an SUV, they all extend the class car. Therefore, you can save them all in the same array, and depending what they are, you might want to change some parameters. Okay. This concludes our lesson on casting. Remember, a subclass can be disguised as a superclass. Okay, that's the main idea here, and the program won't know anything that is not either overridden or directly inherited from that superclass for this variable, unless you cast it back to what it really is. Bye.